So let us just continue with the good conductors. So we have looked at definition of conduction and we figured out what conduction means, which is clear to us. And we have found that the characteristic of conduction as a mode of transmission of heat is that it actually happens without any movement of particles. All right. Now, what do you mean by good conductors? So there could be good conductors and bad conductors of heat. What do you mean by good conductors? The good conductors are substances which all heat energy to which allow, actually I'm sorry, this is a spelling mistake, this is allow, we just correct it right away, which allow heat energy to flow through them easily, right? So there's no issue, very easily they allow conducting uh, heat energy through it. So they are so such substances, for example, steel, copper, iron, all these are examples of substances which are very good conductors of heat, and they are very good materials with which we can make a cooking vessel, right? Why? Because in cooking vessel, the substance which the vessel is made should be a good conductor. If it's a bad conductor, what happens is you put flame below, still the material with which the vessel is made is not conducting the heat, and so what the liquid or the whatever cooking substance which needs to get cooked inside the vessel will never get the heat, and because of that, the whole exercise of cooking becomes futile. So to avoid that, we have to choose substances which are very good conductors of heat to make a cooking vessel. Now, the other example is mercury, right? If you remember, we had discussed about Celsius thermometers and clinical thermometers, right? So laboratory thermometers and clinical thermometers. And we know that the substance, the liquid substance, which is there inside the thermometer, which really in fact gives the indication of the temperature increase or the temperature being measured, is mercury. And the reason why the mercury was chosen, as we remember, we discussed why mercury is chosen, right, is because it's a very good conductor of heat. And so what happens is that it easily the heat gets it easily absorbs the heat and it expands. So mercury is another example. And why? If you look at most of the metals, mercury is also a metal, are good conductors of heat. All right. Now, the other example is cooling coils in air conditioners made of copper. So let me explain what does cooling coil mean. So what happens in an air conditioner is that um, inside the air conditioner. So let us just try to look at air conditioners in a very simple terms, right? So let me just try to go here. Sorry. Okay. So let us look at air conditioners in very simple terms. So if you look at air conditioners, in simple terms, it's like this, right? So let me use different color. Clear, me probably use black. All right. So in air conditioners, what is happening? And this is very simple explanation. It's much more complex than this. So in air conditioner, what happens is that, um, you know, inside this air conditioner, there is what you call a cooling agent which is flowing. In fact, in industry, a material which is used is what's called freon, right? And nowadays there are a lot of other materials also being used for the cooling agent. So now what happens is that um, there's some kind of a tube here, right? So this is a tube, right? And it flows, and here you have what you call the cooling coil. So what is happening is, and here there is a cooling unit. So what happens is this cooling agent keeps flowing through this tube, and when it goes to the cooling unit, this cooling agent gets cooled, right? It gets cooled to very low temperature. So it gets cooled to say 5 degrees Celsius. Then what happens is when it reaches here, the air which is supposed to go into the room. So here there is a room. This is a room, right? The air which is supposed to go, the air actually flows through this tube, which has got very cool cooling agent. And so what happens? The air gets cold, and the cold air comes out to the room. So this is a cold air. And then how is this air becoming cold? Is because the cooling agent is absorbing heat. Why? Because it is at a lower temperature, 5 degree, whereas the air which is in the room is 30 degree probably. So the heat flows from air to the cooling agent inside the tube, right? And so because of the air is losing heat, and when the air is losing heat, its temperature goes down, and so probably when it comes to maybe 15 degrees Celsius. So inside the room, the air is very comfortable and cold. But you should understand, the heat is passing from the air into the cooling agent. So the cooling agent is becoming hotter. Then what happens is that the cooling agent goes into what you call the cooling coil, and goes to the cooling coil. And when it goes to the cooling coil, what happens is that there is a way in which in certain air conditioners, what happens is very cold water is will be flowing into the will be poured onto this cooling coil, and so the cold water will start taking away heat from the cooling agent. And this tube for the cooling agent is made of copper. The reason why it is made of copper is because it's a very good conductor of heat. So when it is a very good conductor of heat, what happens is that the heat which is there in the hot cooling agent now is easily conducted out onto this cold water or cold air or water which takes away the heat from it. So that is the idea. So we need to use a good conductor for the cooling coil. So this is basically the cooling coil. This is a very simple explanation. Don't I mean, the air conditioners are far more complex equipment, but I'm just trying to give a very simple explanation. And this cooling happens. How this cooling happens, you will learn it later on in thermodynamics. So thermodynamics, there is I think it's called the Thomson effect, if I remember. Using that is the concept which is used for the cooling agent to be cooled, and so you'll learn that later on. So don't worry about that, right? So so this is basically what is going on in air conditioner. All right. Okay. So so the good conductors are materials which easily allow the transmission of heat through them, and most of the metals are good conductors. We saw that the cooking vessels are made of steel, which is basically nothing but iron mostly, right? So steel is made of iron, and copper. Copper is another thing which is used for cooking vessels. We have looked at mercury, which is again a very good conductor of heat, and that's why it's used in thermometers. And we looked at copper being used for cooling coils in air conditioners. Now, all these are actually instances of using good conductors, materials which are good conductors of heat for certain purposes, right? But there are, on the other side, substances which are not good conductors of heat, which do not allow flow of heat energy. An example which I gave a little while back was the cloth, and cloth is typically made of cotton, right? And I told you, when your mother wants to take the water kettle from the cooking gas flame, he will hold the handles of the kettle by using cloth. And I told you why she does that is because cloth is made of cotton, and cotton is a bad conductor of heat. And so even though the handle is very hot, the the cotton, since being a bad conductor of heat, will not allow the heat to pass on to your hand. Otherwise, it should flow, right? Because your hand is far more cooler. It's probably it's 37 degrees centigrade. That's our body temperature. Whereas the handle of the kettle probably maybe at 70 or 80 degrees centigrade, or maybe 100 degrees centigrade, right? So if you look at the logic that we used before, because there's a difference in temperature, the heat has to flow from the handle to your hand, but it doesn't happen because between your hand and the handle there is this cotton cloth, and the cotton is a bad conductor of heat, and so the heat doesn't allow the heat to pass through it, and because of that your hand is safe. So that is what unknowingly your mother is using physics knowingly to solve the problem of her hand not to be burnt. And so tomorrow when you see your mother or your sister or brother or your father, taking off something from the gas stove using a cloth, you should say, you know what, you have used physics without knowing. This is what the physics of it is. The cotton with which that cloth is made is bad conductor of heat, and so it is not conducting heat from the handle to your handle to the hand, and so your hand is safe. Wow. Again, application of physics in day-to-day life. All right. So there are different examples of bad conductor. Wood is a bad conductor of heat. And in fact, plastic is a bad conductor of heat. Rubber is a bad conductor of heat. Glass is a bad conductor of heat. So there are several, examples of bad conductors of heat. You might have seen in certain cases, a cooking vessel handle will have rubber around it, right? Or certain type of plastic around it. And that's all because they're all bad conductors of heat. So even if you catch the handle, since there's a rubber coating around the handle, that is a bad conductor. So it doesn't conduct heat from the handle to your hand, and so your hand is safe. The other thing which people do is put a gloves, right? So they put a hand gloves. You might have seen it in the bakeries when somebody has to take off the cake from the oven. They put a gloves on the hand and take it off. That is because the tray in which the cake is baked, that will be very hot, and they don't want their hand to get burnt. So they put a gloves which typically will be made of cotton cloth with stuffed cotton inside. And because the cotton is a bad conductor of heat, their hand is safe. Again, another example. Most of the liquids other than mercury, for example, water is a very bad conductor of heat, right? Gases are bad conductors of heat. So there are several examples for bad conductors of heat. So you looked at good conductors of heat, bad conductors of heat. You looked at some examples of how the property is being used. Being bad conductors is not bad because there are purposes in which those substances can be used, and being good conductor of heat is also great because there are purposes for which those substances can be used. So that's about good and bad conductors of heat. All right, so now let me take you through an experiment, right? So I want to explain the concept of conduction using experiment. And the key point that I want to prove in this experiment is conduction happens without movement of particles. There's no movement of substance at all. So if you look at steel conducting, there is no movement of any particle or substance inside the steel rod when it conducts. That's what I want to prove here. Okay, so let me show you a video first, and then probably I'll explain this. I want to show you the video of the experiment. So this is a simple experiment which kind of shows that how the conduction happens to metal, and when it happens, there is no movement of any particles, right? So let us get into this experiment. So here, what do you have? So you have a wooden block or a brick or something, right? And then this is what's called a hacksaw, right? So this is what is called a hacksaw, and yeah, so this is a hacksaw. So this is, I'll use a different color probably. So this is a hacksaw, and this is made of steel, right? So this is made of steel. So, and so that means it's a good conductor. So it's a good conductor. So it's made of, this hacksaw is a good conductor of heat. And then this hacksaw is attached to a wooden stand or a wooden block. I can say it's nailed onto that. And that's it. So that's what it is, right? So now let's see how this experiment proceeds. So we have made the setup. Now what we're doing is, he is the scientist is just putting a drop of wax, molten wax onto the hacksaw, and he's sticking a pin onto that molten wax. So when he sticks, what happens is that the nail will just stick onto that hacksaw because there's a wax in between, right? So it just sticks. But the property of wax, as you should understand, is now when it cools down, it will bind that nail onto the hacksaw. But when it gets hot, again the wax will melt, and then when it melts, it cannot hold the nail anymore with the hacksaw, right? So that's what we will see now. So let us just go ahead. So now he's attaching all the nails, right? So now we have a setup like this, right? So you have nails attached onto the hacksaw with the wax. And now what we're going to do is, he's just putting a candle. So he's putting a candle. He's putting a candle on the side. Now, let's not look at the experiment. Can you guess what's going to happen? What's going to happen? Now, when he is putting a candle here, what is happening is this end is becoming hot. Here it is getting hot, definitely, right? Because why? Temperature difference. The flame is far more hotter than the hacksaw. So the heat is going to go from the flame onto the hacksaw, and hacksaw is going to get hot. Now, since this is a metal, since it's made of steel, which is a good conductor, what's going to happen is the hacksaw is going to conduct heat. So it's going to conduct heat, right? It's going to conduct heat. So and of course conduction is from a hotter to a colder region. So this is hotter, and definitely this area is colder because here there's a candle kept. So the heat is going to start flowing, or there's going to be transmission of heat through conduction from here to here. And now let us proceed with the experiment, see what goes on. So now after a while, what happens? So heat is going to travel, and you've seen the first nail fell down, right? Didn't you see that? Did you observe it? The first nail fell down here. The first nail fell down. Why? Why did it fall down? The reason is because the heat was conducting, and so after a while, even the heat got transmitted to this area, and because of the heat was transmitted, the temperature went up here also, and because the temperature went up, the wax melted, and because the wax melted, the nail was not held to the hacksaw by the wax anymore, so the nail fell down because of gravity, right? So again, there's a transmission of heat. Now you can see that when the transmission occurred, you cannot see any substance moving on the hacksaw. Hacksaw is just staying as is. There's nothing which is moving inside the hacksaw. It is just staying as is. That is the other point which I want to tell. If assume that things were moving around a lot, then you would have seen the nails also moving here and there, right? With the hacksaw. But you didn't see that. The distances, you can see that the nails between the nails, the distance is remaining the same, and there is nothing going on, right? There's no movement of substance at all inside the hacksaw. So that is a very key point which I want to. Let's just proceed with this experiment, and let us see what happens next. After a little, now you can see that the first nail which fell down was the nearest one. Why? Because it is nearer to the hotter region. So it takes farther away the nail is, it takes that much longer time for it for the heat to reach there. So heat is slowly getting conducted. First it reaches here, then it slowly heat reaches here, slowly reaches here, and so on. So it is getting conducted from the hotter part to the colder part, and further away the colder part is, it takes that much longer time for the heat to reach there. So it's not that heat reaches all these points in one shot, right? So that's the other point that you should to look at. Now look at what happens. After a little more time, the second nail is also falling down. After a little more time, you'll find the third nail also falling down. Here you go. So you can see what's going on, right? So there are multiple things that you've learned here. One is you've seen how conduction works. Second is you've seen that there is no movement of anything in that hacksaw. Hacksaw is just remaining intact when the conduction is going on. And third thing is, the conduction happens from the hotter part to the colder part, and further away the colder part is, it takes that much longer for heat to reach there, right? So that is the third point that you figured out. So there are 3 different points that you learned from this experiment, which is really great. All right, so let us go back to the presentation. Oops. Sorry. Need to open up that again. Clear this. All right. Let me open presentation. So we looked at the experiment. It's taking a while for it to come up. So, so what did you observe in the experiment? I think it's very clear what you observed, right? So, what was done in the experiment is, we had a hacksaw. Here is talking about iron rule. The rule is again a scale made of iron, right, or steel. You can use that also. The experiment which I showed, it was a hacksaw which is made of steel. And what was done is, we fixed those brass pins onto the hacksaw or the iron rule using wax, and then place the ruler on a table, right? And as shown in the figure. So let me also bring up the diagram. So, and then we kept a burner or a candle on one end, and we saw that in the course of time, the nails started dropping one by one, and the nearest nail dropped first, and then the next nail, and so on, right? So this is what we saw in the video too, right? And so we have the burner here. We have the burner here, right? And so the burner was heating, and the course of time, the heat was getting conducted, and first this nail fell down, and the next this nail fell down, and then third nail fell down, and so on in the course of time. And further away the nail was, it took that much longer time for the heat to get conducted to that area, and so it took longer time for that nail to fall out, right? So that's what we figured out in the experiment. So experiment is pretty clear and simple. Now the various points that we understood out of this experiment is what I want to tell you. One is, One is that first point is no movement of particles, right? So that is the first thing that you learned. No movement of particles. Second point that you learned is that uh, you know, further away the nail is, it took longer time for it to fall. So these are the points that we figured out when we actually looked at the experiment. I think it's very clear from the experiment about these 2 points. Now, differences in rate of flow. Now, that's the other important key aspect. So we actually looked at the experiment and we looked at how the conduction happens. We also found that the conduction happens without any movement of particles. We saw that if the nail was further away from the burner, longer it took for the heat to reach there. So it takes time for the conduction to happen, right? So it's not that instantaneously the heat flows to any part. It takes time. Now, but what about the rate of conduction or rate of flow of heat through substances? Is that all the same, right? Will all the substances conduct heat in the same rate? It doesn't, right? So what we can see is that for example, if you compare between copper and iron, copper conducts heat fast in a much more faster rate than iron, right? So we can use let me show again another experiment which kind of proves this part, right? Let me just bring up the diagram. So if you look at this diagram, you can actually see what we are trying to do. So it's a similar experiment, similar to the last experiment that I showed, the video that I showed. Only thing is here, what we've done is we have set up the same thing for an iron rod and a copper rod. And then we have put a burner in between, right? So that the burner heats the iron rod, it also heats the copper rod. Now you can see that when you do this experiment, you can see that the first pin which will fall down is a copper, is a pin which is attached to the copper, the first one, right? After it falls down, after a little while, the first pin of the iron rod falls down, which basically means that the copper was conducting heat in a much more faster pace or faster rate than the iron. That is why the first spin of the first brass pin which is attached to the copper fell down first, right? Because it could conduct heat in a much faster rate than the iron. So that is what this experiment shows. So that is basically what we're trying to do. So we have an iron rod with brass pins fixed with wax, copper rod with brass pins fixed, right? And then we're heating both the rods, right? So you're heating both the rods and they are of equal lengths, right? And we are heating both the rods, and then we find that, and what do you find? We find that the pin 1, right? So we find that the pin 1 of the copper rod falls, and then pin 2 falls, then the pin 1 of iron rod falls. It takes so long, much more longer for the iron to conduct heat. So we find first the copper rod's first pin will fall, then the second pin will fall, right? Then you will see the first pin of iron rod falling. Even though the distances are exactly the same. So this distance is equal to this distance, and this distance is equal to this distance. Let me just show that. So this distance, right, this distance and this distance is the same. Both these distances are the same, right? And this distance and this distance is also the same, exactly the same. Even then, what you find is the copper rod conducts the heat in a much more faster pace. So you'll find first the copper rods, the first brass pin in the copper rod falling, second brass pin in the copper rod falling. Only then you'll find the first brass pin of the iron rod falling. So by the time the copper is conducted all the way up to here, the iron has only conducted up to here, which basically means the copper conducts heat at a much more faster rate than the iron rod. That's basically what it is. All right. Okay, so let me close this. Let me go back. Okay, so that's basically what it is. So this experiment is showing that different substances or different materials have different rates of conducting heat. So here, for example, in this experiment, we found that copper has a higher rate of conducting heat than iron. All right. So let us just get into the next slide. Now, I'm going to actually discuss what are the applications of insulators. What is insulator? Insulator is nothing but a bad conductor of heat. That's all what it is. Insulators are bad conductors of heat and hence can conserve energy. Very important point. They're bad conductors of heat. Insulators are bad, so they conserve heat. Why conserve heat? Because they don't allow the heat energy to go out. They keep it inside. Right? And a simple example is what you always, something that you do always in a winter. What do? You wear woolen clothes. And why do you wear woolen clothes? Why do you wear woolen clothes in the winter? The reason why you wear woolen clothes is because the woolen clothes is made of woolen yarn, and in between the yarn there is a lot of air. There's a lot of air trapped between the yarn, and air is a very bad conductor of heat. So what happens? The body is at 37 degrees, right? So let us try to draw your body. So this is your body, okay? So this is your body, right? So shoulder and neck. I'm not a very good artist, so pardon me for that. Now, what you have done is you have worn a sweater on yourself, right? So this is your sweater. So this is your sweater, right? So let me use a different color for sweater. That's better, right? So this is your sweater which you have worn above on your body. So this is your sweater which is your worn on your body, right? So the blue one is your sweater, right, which you put on your body. Now, what is happening? The body is at 37 degrees Celsius. And during winter, probably if you're in a place like Delhi, the temperature outside may be 5 degrees. So there's a temperature difference. What will happen? The air is at 5 degrees, your body is at 37 degrees, and air is coming in contact with your body. So what will happen? The heat will start getting transferred from the body to the outside air or outside atmosphere because of the temperature difference. But what is happening? You have got an insulator coming in between. Why? Because you have put a woolen cloth, and the wool itself is a bad conductor of heat, and over and above inside the woolen yarn, between the woolen yarn, the yarn is basically the threads of wool, there's a lot of air too. So the air is even more bad conductor of heat than the wool. So together they become a very good insulator, very bad conductor of heat, and so it prevents the heat from flowing from your body to the outside atmosphere, and so you feel warm, right? If you didn't put the woolen cloth, then there's no insulator on your body. All the heat that you have in your body you start losing very quickly, and you start feeling cold, and after some time you may start shivering and all that stuff. So that is what the woolen clothes magic is. Again, physics, right? So you've learned the physics of why you're putting a woolen cloth on yourself when you're winter. Very good. Now, what about blankets? Why are you using blankets during winter? Again, it's the same reason, right? When you're putting blanket over you, the blanket is made of wool, and the woolen yarn, and there's also air inside. Very good insulator. Doesn't conduct heat out of your body. Warm and cozy. Now, sometimes we also use two thin blankets. I don't know whether you've seen when you go to hotels and stay in places like Ooty or in Kulu Manali or probably such places or Switzerland. You can see that the bed will have two blankets, one over the other. Why is that so? The reason why you have two blankets is how, so you're lying on the bed like this, right? So this is how you're lying. So this is you, right? So this is you, right? And then what you're doing is you have got two layers of blanket on you. So this is one layer and this is the other layer, right? Of course, it'll be like this, right? So not really a straight line, right? It's a blanket. So when you put two layers like this, each layer is an insulator. So this blanket is insulator, the first blanket is insulator, second blanket is also insulator. In between there is air gap, right? Because there are two blankets. Between that there will be air gaps, air trapped between those two. That is a even more bad conductor. So together, this two blankets and the air gap between, so there's air gap here, right? All together becomes a far more better insulator than just using one blanket, right? So if you use just one blanket versus you use two blankets, that air gap coming between the two blankets is also a wonderful insulator, and so you feel far more warmer, right? So that is basically the interesting part. Now I want to show you. Now a lot of people have asked me this question. Vinod, I just don't understand. These Eskimos are making igloos out of ice. Why are they doing that? Ice itself is very cold and they're going to sit inside. Don't you think that they're going to get even more colder? Has this question come to you anytime? I'm sure you might have, right? But there is again a physics. Why they use why they make igloo out of snow, right? So let us just see a small video where I want to actually show you how this works. Right. So here you can see two Eskimos building a igloo, right? Now, this should be most probably in a place called Alaska. I don't know whether you've heard about. Have you heard about a place called Alaska? It's a place called Alaska. It is northernmost. It is to a northernmost part of North America, where temperature is very low and most of the year it will be snowing, right? And that is where you will find Eskimos, right? Now you can see this is a father and a son Eskimos who they're building a igloo. And what are they doing? They are actually chopping off snow, right? And you can see that they're chopping off snow and they're making big bricks out of them, and then they're putting it one over the other, and that's how they're making the igloo, right? I'm just moving ahead. So you can see that they're putting it on a sledge, and then you can see what they're doing. They're putting one over the other, right? So you can see that they're putting one over the other, and the course of time, let us and see, and then they kind of chop it, shape it properly, and and they have the whole thing covered, and they have got a small door, right? So this is how the igloo looks like, right? So the igloo, all these are all this all this is bricks of snow, bricks of snow. Now, why are they using snow to make igloos when it's so cold outside, and snow is also will be snow is water, frozen water, right? Which basically means that it is 0 degree or even below that, right? So why are they using it? The reason why they're using is that's actually one of the best sources they have to build the igloo. First is it is available abundantly. The second is the snow. If you look at the snow, even though from outside it looks like a solid stuff, the snow is inside, the snow has trapped a lot of air. So actually this brick is nothing but a lot of snow particles sticking together, and in between those snow particles there's a lot of air. So it's like this, there are a lot of snow particles like this. If you use a microscope and look at this bricks of snow, that's what you'll find. So there's a lot of snow particles, and in between there's a lot of air gap. So this is the air gap, a lot of air gap. And this air gap, which is air trapped inside the snow, is a very good insulator. Of course, even the snow itself is a good insulator because it's made of water, and water is not a good conductor of heat. So water is a good insulator. Plus all these air gaps which is trapped inside the snow particles in this bricks of snow, that is even more a bad conductor of heat. And so together, those bricks of snow, they are very bad conductors of heat. They are very good insulators. And so what happens is when they put a fire inside the igloo, and also their body heat, right? The body heat that the Eskimos have, plus the fire they put inside the igloo, all that heat which is there inside the igloo is never going out, because the bricks of snow with which the igloo is made are very good insulators, and so they don't allow the heat to pass through them, and so the heat remains trapped inside the igloo, and so they'll feel very warm and cozy inside the igloo. That is the reason why the igloos are made of snow, and still it is so comfortable. All right. So that's about igloo. Let me just go back here. So Eskimos make igloos out of snow because it has good amount of air trapped in it, as I explained, right? So between the snow particles, there's a lot of air trapped in. Thick fur on animals. Again, you might have seen, right? Polar bear or reindeer, all these types of animals which live in very cold climate where there's a lot of snow and so on. For example, Alaska has polar bear, right? And the polar bear is covered with thick fur. So actually, if you look at their body, they are. I'm just drawing a simple how their body is. So this is polar bear's body, and you can see a lot of fur on their body. So this is fur on their body, right? Fur on their body. And then, in fact, inside their skin, just below their skin, there's also a layer of fat. There's a layer of fat that's inside their body, inside the skin, okay? Now, both are very good insulators. So if you look at the fur, this is a fur, right? This is a fur. Now, fur is what? There's a lot of hair, and inside the hair, there's a lot of air trapped, right? That's how it is. Inside the air, inside the hair. So, fur is, what is fur? Fur is lot of hair, H-A-R, hair, and air trapped inside. So in between all these hair, there's a lot of air trapped, and together, the hair is a good insulator. Plus all this air trapped between the hair of the fur, that actually makes like a blanket, right? So it's as if that the polar bear is just want a blanket forever, because always the body is going to have that fur. God has given it, nature has given it, right? So that fur is acting as a blanket. The same explanation that I gave for a blanket or a woolen cloth that you wear during winter, it's just like the polar bear has a permanent woolen sweater which it has worn on its body. And then the other thing which nature is giving is that inside the skin there is a layer of fat, and that fat is also a very good insulator. So you have this fur and you have the layer of fat. Both are good insulators, and insulators means they don't conduct heat. So the heat which the body has is retained. This prevents the heat to flow out, even though outside temperature is much more lower. So that is actually how the fur works, right? And fur helps. Sorry. All right. Now, what about thatched roof? So I actually want to show you some videos again of how a thatched roof looks like. right? So let me go and show you. So this actually is a video which showing how the thatched roof is made. And if you look at the material, this is actually straw, right? So let me just uh, that's it. So this is straw, and between the straw, so again this is straw, and between the straw there's a lot of air trap. So let me use a different color because it doesn't look to be visible. Okay, so between the straw there's air trapped again. So the straw itself is an insulator. It's not a good conductor of heat, right? So this is the insulator, and the air trapped in between the straw is even more a better insulator. So together, when you're using the thatched roof, when you're using straw to thatch the roof, the straw stack or straw bundles which are used, right? It is full of air trapped inside, and because of that, they become a very good insulator. And so, because of that, thatched roof becomes a very comfortable. Thatched roof houses becomes a very comfortable place to live in. The reason is when it is very hot, what happens? So let us look at a house, right? So this is a house with a thatched roof, assume, right? When it is very hot outside and sun is very warm, it's very hot outside. The temperature outside is very high, so maybe it's 40 degrees centigrade outside. Temperature inside home maybe is 25 degree centigrade, or right now the heat wants to flow from outside to inside, but this is thatched roof, not a good conductor of heat. So it will not allow the heat to flow from outside to inside. So because of that, it becomes comfortable inside. Whereas during winter days, let me just erase this slide. So, so okay, so this is winter. So during winter, what happens? The outside temperature is going to be, so let me remove this. So outside temperature is going to be maybe 15 degree, and inside temperature probably is still 25 degree. We want to keep it warm and cozy, right? Now at this point, the direction of heat flow will be this way, from inside house to outside, because outside is cold. Again, because of the thatched roof, which is a very good insulator, it will not allow that heat flow to happen. So both in summer and in winter, the thatched roof is going to help to keep a comfortable temperature inside home. Right? So that is why thatched roof is used. I mean, people who cannot afford to make very, tile roof and so on, they use thatched roof because that still gives them a lot of comfort and takes care of them in summer and winter, and gives a comfortable, temperature inside the house. So that is actually about the thatched roof. All right. So that's how the thatched roof helps you. Now, the same effect on false ceiling. Now, let me show you about false ceiling. So, this is an example of false ceiling. So, you look at this. So, what is happening is that this is a real roof. So, you can see this is a real roof, and there is a false ceiling below it, right? So, this is a real roof and there is a false ceiling below it. So, this is a false ceiling. So this is a false ceiling, right? So let me just use that, show it, mark it using a pen. So this is a false ceiling, right? And then let me just go ahead with the video and let me show the real roof. So now this is a false ceiling. So this is the real roof. Okay, let me just show it once again. So this is the real roof, right? So let me clear this. This is the real roof, and this is a false ceiling. So what is happening now is precisely this. So you have the roof like this. So this is your roof, and how can I show that? All right. So this is your roof, right? So this is your roof, and below that there is a false ceiling, right? So below that there's a false ceiling. This is a false ceiling, and between the roof and the false ceiling there is air gap. So between the real roof and the false ceiling there's air gap, and that air gap again acts as an insulator. And the story is just the same, right? Because the air gap acts as an insulator, it doesn't allow the heat to come to flow from outside to inside, neither it allows the heat to flow from inside to outside. So the same concept as thatched roof. So this is another thing which people use where they want to keep a comfortable temperature inside, and they can use false ceilings to do that, where they maintain a gap between the false ceiling and the real roof, and the roof is the one where the light for the sun rays and sunlight falls, and so roof gets really hot. But because there's the air gap between the roof and the false ceiling, the heat actually doesn't flow because the air is a big insulator to the false ceiling, and so inside it becomes far more comfortable. So that is the concept of false ceiling, right? Sorry, let me clear that. All right. Okay, so let's go back to the presentation. Wood and plastic handles for kettles, I've already explained, right? So when you use a wood and plastic handles for the kettle, because they are bad conductors of heat, even though the kettle is very, very hot, the heat does not flow to your hand because the wood or plastic is a bad conductor of heat. Similarly, the other thing which I want to talk about is how the sawdust is used to cover slabs of ice. So typically what happens to ice? Ice, if it is kept outside, will start melting. Why? Because ice is at 0 degree, outside temperature maybe 15 or 20 degree, heat starts flowing into the ice starts melting. So what usually is done is, when you have slabs of ice and it has to be transported from one place to another, one thing is, of course, you can keep it in refrigerators and transfer. The other thing which can be done is, if it is only for 5 or 6 kilometers, a very short distance, the ice merchants do is they put sawdust. Let me show you how the sawdust looked like, right? So I want to just show you how the sawdust looks like this. So this is how a sawdust looks like, right? It's like a powder of wood. You can see, right? It's powder of wood. That's what it is. And so wood itself is a bad conductor of heat. Plus the sawdust, since it's like a powder, there's a lot of air trapped inside between the wood particles. That is also a very good insulator. So together, the air trapped and this wood particles, both of them are very good insulators, air being a far more better insulator. Together, what it does is it actually forms like a blanket. So if you put a lot of sawdust on above the slab of ice, it actually will be like a blanket. It acts as a good insulator. It doesn't allow the heat to flow from outside into the ice, right? That's what typically will happen. And because of that, the melting of ice will be far more slower, right? So that is how the sawdust can be used. And so this is actually how the sawdust is. It is usually produced in wood mills, where they cut wood right into different shapes. At that point, some part of the wood will come out as powder, and that powder is what is sawdust. And so that can be used to cover up slabs of ice to keep it, keep it frozen and reduce the rate of melting, because they act like a blanket because they're a very good insulator. Again, another example of practical use of insulator. ഇത് ഫുൾ റെക്കോർഡിങ് കോളായി. ഞാൻ വരികയാണ്. ഇത് ഈ സംസാരം എല്ലാം കൂടി വരികയെന്ന് പറയണ്ടേ. ഇപ്പോൾ ഫുൾ എഡിറ്റ് ചെയ്യണം.